as we are aware that these webinars are recurring webinars and we'll be having it on a weekly basis. So last week, we already conducted a webinar on algebra part 1. So today we are just going to continue with that part on algebra part 2 and some equations and functions of it. So today as a presenter, we have Mrs. Shraddha Naik, who is currently heading the math department at Oberoi International School, Mumbai, and is also an examiner. Previously, she has taught at American School of Mumbai and in international schools in Japan and Malaysia. As an educator for over 20 years now, an experience in integrated math program, MYP, IGCSE, and IBDP, her focus has now been on how mathematics is contextualized across the wider curriculum alongside students' discrete mathematics learning. So let us welcome Ms. Shraddha Naik.
Yeah. Thank you, Swati.
Yeah, over to you, ma'am.
Yeah, thank you. Good afternoon, everyone. Yeah, thanks for joining us. So I'll be sharing my screen and here we go. Yeah. Is my screen visible?
Yes, ma'am.
Yeah, okay.
Yes.
Right. Yeah, so today the focus will be on algebra and functions. There'll be a lot of graphing, and I encourage you to bring out your TI-Nspires and work along, all right? If you've been attending the past few webinars, I think you should be familiar by now, and you should be able to follow along, right? So unless you use the calculator, you will not find how efficiently and how effectively it can enhance your understanding of math. Okay, so using it regularly is really critical. All right, so let's start. So what I'm going to do is there will be a lot of graphing, so we'll be using the calculator page, the graphing, and a little bit of lists and spreadsheets. Okay, so just so that you are aware. Also, I hope you are familiar with the approach to solving problems. There are two ways you can do that: opening up a problem and opening up a page. Okay, usually for every new problem you would add a new problem. Every new problem would be on a new problem setting, and if you have to solve it using additional applications, you would add pages to it. Okay, so today my focus is going to be how we are going to define functions. There are three different ways, and in certain times there are one way you might like to use over the other. All right. We're also going to look at composite functions, inverse functions, and how to graph piecewise hybrid functions. Just as time permits, or we'll carry it over to the next session. All right. The exam questions in functions and algebra often require you to solve, and this can be done in a variety of ways in the TI-Nspire. So I'm going to try and solve a couple of questions, so you see, how efficiently you can move through the problems. So first I'm going to start with something. So if you have noticed, 2.1 is a new problem. It's on a new problem setting. 3, this indicates a new problem itself, though I've got a notes page on it. I've got some text written, but it is a new problem. And the 3.2 is an additional page to the 3.1. All right. So I will draw your attention to these important bits. Okay, as you are okay. So if you see, the 4.1 is a new problem, and I do not want to get confused with my variables that already could have been defined in 3, and hence I am opening a new problem, which is 4, right? And yeah, so I'm going to kind of start at 5.1, and we're going to start something with a quadratic, all right? Again, we're going to define, and I want you to follow along and try as we move, all right? So this is what I'm going to do. I'm going to start with and solve. Okay, so this is, so let us first define, let us first define. So the more frequently used is if you go on the calculator page, there is a menu. All right, whenever in doubt, go to menu. And if you go to doubt, if you go to menu, you will see different approaches here, different applications, and you would go to actions. You would go to actions, right, and define. So I'm going to define, going to actions. Now, if you see these numbers, I can also use these numbers. So when I'm in actions, there is an additional sub menu which has opened up, and I'm interested in define. So what I can do is when in actions, I can just press define. All right, when I press 1 instead of clicking on that sub menu. Okay, now I'm going to define a function, and I'm going to say f of x, okay, equals, and it is going to be 3x squared, 3x squared. I want you to follow if possible, minus x minus 2. Okay, and I define this. This is one way to define. All right, now let's say I want to solve this. Solving means you are trying to find the solutions, which are the x-intercepts. Different ways to say, to solve this, okay? It is to find the x-intercepts, you call it solutions, you call them zeros. These are all finding the same thing, right? So one way to do that would be to go to menu, right? And now if you go to algebra, you have the numerical solve, okay? You'd solve that. Now, since I've already defined here, I'm going to write now. You might notice that my f of x has turned bold because it's already been defined. The calculator kind of registers that. Now, if f of x was defined in the 4 problem, that would have been a different f of x. It wouldn't get confused, all right? So this is redefined on a new problem set. So that is very important to note, okay? And since solving an equation means equating it to 0, you cannot solve an expression. You solve equations. So you would equate it to 0, right? And you need to let the calculator know the variable that is involved in the. So you draw comma, you define the x, all right? And I am going to press enter. Now, what do you notice? You notice that I've got one solution, but you would expect it to have, because this is not a perfect square, you would expect it to have 2 solutions. So here's the thing, NSolve only gives 1 solution, all right? But you can go ahead, and since this is negative here, you know one of the roots is positive and one of the roots is negative. So you can still use NSolve to get the other root, and this is how you would do it. Okay, you would press enter, right? You would go to control equal sign, which gives you the such that, okay? And you'd say, okay, I'm finding the other equation, the root, where x is greater than, you do the control action again, the control equal again, is greater than, because you already know if one is negative, the other is positive, because the constant has got a negative sign. The 2 roots, there's one positive root and one negative root. You say it's greater than 0 because you already got, okay? And you press enter and you get the other solution. Now, you might say this is not an most efficient way of doing that. It is not. There is another way to do it, but this is an additional way. Sometimes you need, this could be useful in some situations, all right? So the other way is to find the roots. So you go to menu, you go to algebra, and you go to polynomial tools, all right? And you find roots of the polynomial, right? So the degree of the polynomial quadratic is 2, so we are okay. Now to move in between fields, to navigate through these fields, you use tab, you go down. So your You're okay with the 2 because it is a quadratic with a degree 2. You go down, you are looking for real solutions, let's say for now, and you're okay, and you press okay. All right. And now you write the coefficients. And the coefficients are, it is 3, it's 3x squared. Again, you use tab. It is -1. The coefficient is -1. And tab again, and it is -2. And you press OK. You can use the tab. And then once you're here, you press enter. Okay. If you've noticed, we got the same function here, right? Here. But you should notice, you have to notice that there is no equal sign. This is the difference between nsolve and polyroots. You're finding the roots. So the calculator is in fact taking care of equating it to 0 and figuring out the roots for you. All right. And now you press enter. And now you see you get both the roots. All right. You get both the roots here. In the earlier nsolve, you got one at a time, and now you get both. Okay. Now I could go to menu, right? And I might, sorry. Oh, so every time you are not in the right window, you just escape. Okay. And now I want to go to menu, and I want to go to number, and I want to approximate it to a fraction. Okay. And I press enter, and you get your fraction. Right? So it is -2/3 and 1. Do I have any questions at this point? Guys, do I have any questions at this point? Yeah, you could just write in the chat box and Miss Swati will let me know, right? Okay, so here we are, we got the roots, right? Now let's go ahead and let's change this. So I might want to go up, and the way to, again, to copy is to you go up, you use the upper arrow, right? And you press enter, right? I want to change this. I want to change this to a negative to a positive. So I use my navigational arrows, and I delete the negative, and I just write a positive. Let's see what happens, right? Let's see what happens. I press enter. There are no solutions, right? There are no real solutions because this entire quadratic is definite positive. It lies above the x-axis, right? So let's say I want to find the roots, the imaginary roots, the complex roots. Can I do that? Yes, of course you can do that. So I'm going to now go up, and I'm going to copy this, right? And just add, I'm going to use my navigational keys to go back. And since complex roots, I'm just going to add a C, the C polyroots. You can find the same menu, and I'll show you how in the menu, the earlier menu. All right. Okay. And I press enter. And these are my complex roots, right? These are my complex roots. Now, if this is a little distracting, you want it in 3 significant figures, right? All you have to do is go back to the document. Go back to the document. So you can go home, right? And you can change the settings, the document settings. So I'm going across to settings. And if you see, I want to change the document settings. I want to show this to you, and it is in float 6. So float 3, you can use float 3 for 3 significant figures. And you can go okay, right? And I can go to my current document, all right? And I'm going to now go back and press enter. Right? And if you see, if you notice, I've got 3 float. So it is already, you have this in, if you've noticed, this has been in 3 significant figures. So this is float 3 is a really useful tool for your document settings. All right. Now, if you've learned, if you are in AAHL course, you might have been introduced to the sum and the product of roots, right? The sum and product of roots. Now, if you have done, let's do the sum. Let's see if you get the sum, because the sum of the roots, right, is -b/a. Let's see if we get that, right? So what I'm going to do, is go up. I'm going to press enter. So I'm copying and well, I could have, and if you've noticed, if you copy the whole thing, you get the extended value. You get all the extra decimal numbers, right? And then I go back. I could have written sum first and then copied. It doesn't matter either way, but I just wanted to show you, this webinar is sometimes very dynamic, you know, when I'm showing you certain things, I think of extra things to help you out with. So you want to find the sum, right? So you go to sum, right? A bracket, press enter. You should be getting, it is negative b over a. So let's see what you get, right? So it is 1 negative of negative is positive. It's 1 over 3. Again, if you're interested, you can go to the menu. You can go to the number. You can go to approximate to fraction and press enter. And you get 1/3, which is negative of -1, which is positive. 1 over 3 gives you the sum of the roots. All right. Let's try one with a polynomial. All right. If you are in an AAHL or AIHL class, you would have been introduced to polynomials. And let's do one polynomial function, right? And let's see if this works for that one. And so now let's define it using a different way, right? I said we'll show you different ways of defining. And I'm going to define now, I'm going to call it P of X, because I've already defined f of x, so P of x, right? And now, the other way to define is to use this notation here above the template, right? But it's in blue. So you've got to use control, template. This is the notation for defining functions or defining values, right? And I'm going to write, this is a new function that I'm going to do. So this is good practice for you. If you have your calculator, if you have your handheld, or you're working on your computer on the soft copy, then this is good practice for you, right? So you go to x cubed, right? Notice that you have to use the right arrow to be in line with the expression. Okay, it's plus 2x squared. Let's do plus 2x squared. Minus 5x. So since x squared is already kind of, we have a special key for the x squared. It is in line with the expression, so I don't have to use the navigational keys, the right arrow. Little things that you need to pay attention to, okay? Minus 5x minus 6, okay? And I press enter. So it is defined. So we use this, this is a different way than the one that we used earlier to define a function, right? Okay, now you must have done factor theorem and remainder theorem. Possible, it's possible you've done, right? So if I want to find if this is divisible, exactly divisible by a linear polynomial, which is x minus 2, all right, if it is x minus 2. So what I have to do is I've just got to do P of 2, right? So if this is a root, then let's see what happens, right? Then there is no remainder. It is exactly divisible by 2. So this tells you that 2 is a factor of this polynomial, okay? So this is one extra way that you could use. We could also use the polytools. Let's go ahead and do the polytools now. So let's go here. Let's do the algebra. I don't want to use the nsolve right now. I'm interested in doing the polytools, okay? So I go to polytools, right? And if you see the complex roots, the C poly roots was the complex roots earlier, that one I used. I want to find the real roots, right? And I can copy this here, put it here, and I press enter. Oops. Okay, oh, so let me go ahead. I need to define. So let me go ahead and explain what could have gone wrong. If you have looked here, the polyroots, it's got to define the X variable. So that's what it needs. So I'm going down. I copy. See, the copying is one of the best features. You just have to go, scroll up. All right, you just scroll up using the navigation tools and press enter, and then go back, define the variable, which is X, and press enter. And these are your roots. So what we discussed earlier, whether 2 is a root, it is a root, all right? And if you would had, so let's do the remainder theorem again. If you had plugged in -1 or -3, you would have gotten a 0 as a remainder. Let's do this for one. Let's do it for another one. Let's see what happens using another one, except for, not one of those, not one of these roots. Let's use another. Let's use negative, or let's use 1. And let's see what happens, right? It is not a root, and that is why you end up with the remainder of -8. This is the remainder theorem, right? So having done that, okay, now if you have gone here, you could have found the sum, all right? So let's do that again, so that, I want to show that again, right? And if I press enter here, right? And if you see, because it has been, these are exact numbers, but because the calculator is using so many decimal places, you might see that it is, written in a form that looks really weird. Going back, let's use the sum. Okay, let's use the sum. Oops, I'm in the wrong place. So I need to go back and I write the sum. Well, you don't have to really use the sum, because you do know, right? It is -2, but I just want to show you what things you can do with the calculator. Like we used earlier, we used it for complex roots, and you did see that it worked for the sum. So I want to do it, I want to discuss a little bit. Yeah, and right, and you do enter. You should expect, well, you can add them, right? And you press enter. Okay, it is -2. Now, why is it -2? Because it is minus b over a. So -2 over 1 will give you -2. That's the sum, right? Moving on. I do want to show you a good feature about, now let's move into graphing. Let's move into graphing, okay? So if we were to graph this, now that we have, if you've seen here, I can just scroll up here. We've already defined P of X, right? Now I am in the same problem. So I'm going to add a page. I'm not adding another problem. I'm adding a page. To add a page, if you see plus page, it's so self-sufficient. It's just self-explanatory here. You add a page, going to control, and it asks you what you're interested in. Well, I need a graph page. And now I can just graph P of X because it's been defined. So I can go ahead and see there is so much dynamic interactivity between these pages. So you can do P of X. Okay, and I press enter, and here is the graph. You can find these roots. Of course, you can read them off here, but let us find out a way. If there are some new people who have joined today, I do want to take this opportunity to show you how to find out. Okay, so we can analyze graph. All right, I can use these numbers to get to the place I want, right? I'm interested in 0. So I can just go here and click 0. Well, it is in the wrong place, right? You've got to be in the right place once you're here, and you can do the zeros, right? Now for the zeros, you may be interested in just 1 0. So this calculator has got the capability to find zeros one after the other. So it asks you for lower bound, right? So the lower bound is good here. You go over and you find the first zero. We had the first zero is -3. You can do the same thing. You can analyze graph and you can find the zero. And if you want, you have you've got to locate the other zero. So your lower bound is to the left of the zero, the upper bound is to the right of the zero, and your other root is -1. And let's do the third one as well. So you go to menu, you analyze graph. Please work with me. Just gives you a little bit of confidence in using. You cannot have it over. You need to have it under. So you click here, you scroll gently across, and you click here and you get the other one, right? If I'm interested, so I escape here, and now I'm interested in just pulling this fellow, just yeah. So if you see the hand, if you see the hand that pops up, I can just lift it and I can put it in a place where it is easy for me to kind of read off, right? I do not want a lot of overlap, so I might just want to place them in a place where I can read them. So I'm just showing you different things you can do. You wait for the arrow to pop up, right? And then you can move it to the side. So these are your zeros, which are consistent with our finding. Okay, all right? So now we are going across to find, I can show you a piecewise graphing. I'll show you a piecewise graphing. All right. So to get to the entry line, you go to tab and you get the entry line, right? In the f of x, I had graphed this function, okay? The function, the polynomial, the cubic function. Now I'm interested in graphing a piecewise function. So what I'm going to do is go up, all right? And right now I'm not interested in looking at this function, right? I'm graphing another one. The zeros, if they are distracting you, we can open another problem. All right, so let's go ahead and open another problem. If this is a little distracting for you. So to open a new problem, you go to document, you insert a new problem. All right, we start on a fresh slate, right? There's no baggage of other, of carrying over variables or functions from other problems. So there isn't any possibility of confusion over variables or equations or functions, right? So let's go to the template, right? Oops, yeah, okay. Can you see it?
No, ma'am, the screen isn't visible.
Oh, it just closed on me. Just
Yeah.
the TI-Nspire just closed on me. So I will just try and regain it. Yeah, I just have to. Do we have any questions, Swati? Oh,
Ma'am, we have one question. How do you solve sum and product of roots without the calculator?
That's teaching mathematics. So that will not be discussed here right now. Yeah, they will
Yeah.
learn when in their course, right? This is
Yes.
yeah. Okay. So all right. So I'm just waiting for it to open up. Let's see. So to answer the question or to guide students along that is that it is part of your curriculum. So you will do it in your classes, in your math classes. Okay, so you don't have to worry about that. So now I'm just trying to go back to my. Give me a minute or two. see if this works. Yeah. Okay. All right. I'll start sharing the screen again. Yeah. Now what we have covered is possibly is not stored. You know, what we just did has not been stored because it quit on me unexpectedly. Right. But that doesn't matter. We'll just do another. We'll insert a new problem. Is it visible now?
Yes, ma'am, it's visible.
Okay. Right. So we'll start in graphing. All right. There are two ways you can define a piecewise or a hybrid function on the calculator page and then have it graphed on the graphing page. The other way to do is to use the graphing page itself, right? So you go to the template, okay, and this, I'm going to use this, right? I'm going to use this, oops. The template, right? So okay, so I'm going to create a piecewise function and I'll let you know what it means. Okay, so this part, a piecewise function, right, is a function that is made up of different functions. So essentially, this is really useful for modeling when you have your math IA, to work on your math IA. If you're going to model data, and if the model that you are finding is not a good fit, then you could use different functions to model that data. All right. So I'm just going to show you an example of what it means by a piecewise function and how you can graph here. Okay. So let's graph the first one, right? I'm going to use the fraction, the fraction one here, and I'm going to call it, it is 3/2x, and you use tab again, and x, right, -2, right? And I've got domain restrictions for this function. I've got domain restrictions for this function. Let's say I'm going to graph it from -2, okay, from -2 to 0. So I'm going to do -2, okay, -2. I'm going to go to control equals because this is where I find my inequalities, because I've got to say what the x lies between. It lies between -2 and 0. And the 0 is less than 0. Oops. Okay. It is less than 0. All right. And now this is one part of the function. I'm moving on to the next one. The next one is x squared. Let's say it's a quadratic. It's x squared minus 2. So it's x squared minus 2. All right. And this function exists from 0 to 2, right? Now, since your function does not exist at 0, right, I can say, okay, so then it exists, so it is between 0, control equals, right, and I'm going to say less than or equal to x less than, again, and this time it is less than 2. All right. And the third function, I'm going to use an ln function, a logarithmic function. Okay, I am trying to use different kinds of functions, and I go to logarithmic functions, and if you see the ln, it is the natural log function. Okay, if you haven't done logarithmic functions, you will be doing it sometime this year. So, you can, it is a natural log. If you haven't come across it, no worries. So you go to control, the exponential one, so you get the ln, and now I'm going to say 4x. Let's say it is 4x. Right? So these are my different functions. And again, I've got to define the domain, and it lies between 2 and 5, and 2 being included, 2 included. So I go to control equals, excuse me, I go to 2, and then you go to controls equals, this gives you, right? And then since 2 is not included here, I can include the 2 here, x and less than or equal to 5. So you go to control equals, and this one, and less than equal to 5. So I hope you got that, you got it on your handhelds, right? And I'm going to graph it, right? And if you see, I've got 3 different functions. Now what you can do, you can really, mathematical presentation is one of the 5 criteria for your math IA. And what I can do is I can click on this one. So now here is where the context menu is really helpful, right? So I can go to control menu. Excuse me, yeah, okay. So I'm clicking on this one, this particular function, right? I do the control menu, and maybe I'm not in the right place. Okay. Okay, and you see color, you can change the color and the attributes, and this is one thing I wanted to show you, so I can just have it different color, because mathematical presentation, for it to be effective, you've got to really use different kinds of and different ways of representing your data. And I can go in and color here, and let's do the line color, and I can choose, let's say I choose red for this one, for this bit, and then, well, it colored the entire thing. I wanted to just change individual parts, and you can do that by highlighting that. All right, I can also go and do the menu. Again, I've got to use the control menu, because I'm going into contextual menu. You go to highlight, and that's where, okay, and then you go to control menu, you go to the attributes. Now what do attributes do? You can use different characteristics. You can have it bold, so if I increase the bold, the boldness of the line, right? So to make it more striking, if you have to discuss something about this part of the function, you can have this emboldened, right? You can change, so I'm going down here, and you can change the way that it is drawn. You can have it as dots, you can have it as dashes, okay? And you can change, so here it tells you what it does. You know, it is such a self-sufficient tool, because it just tells you what it does. Its line is dashed, and you can go ahead and do the label style. You can label parameters, you can show names, and you can explore that by yourself. So this is how you would graph a piecewise function. Okay, that was one thing that I wanted to show you. Now the next thing I really want to do is, before is introduce you to inverse functions, right? And next time we will do an activity on, or maybe if we have time, we'll just do it today. So I want you to open up a different problem. So you go to document, you insert, and now I want to go on to a problem. Okay. This time I want you to start with graph. All right, start with the graph. We'll also need data and a lists and spreadsheet page. So I want you to do that. If you are working with me, I'd want you to add a page, because we're working on the problem. And this is lists and spreadsheet. Go to the list and spreadsheet here. Okay, so I want these 2 pages opened up right now. So let's start with x cubed. So here is what I'm going to do. I'm going to start with the x cubed function. It's a cubic function, a cubic parent function. Okay, and I'm going to graph it. And today I want to teach you a little bit about inverse functions using graphing, right? So what we are going to do is, you should know that inverse functions are symmetrical over y equals x, right? And that is what I'm going to try and do that, okay? So right now, what I want you to do is go to menu, go to geometry, menu, geometry, points and lines, and point on. I'm going to show that again. If I want to get rid of this, and here, in fact, if you don't know what this is supposed to do, you can just highlight, okay? Just hover over this icon and it lets you know what you need to do. You click the object and then the location at which you want to create the point. I'm going to show that again. So to get out of the application, all I have to do is press escape. And let's do that again. You go to menu, you go to geometry. So what I can do is just click 8. Now I'm just doing numbers. I'm doing 1 and I'm doing 2. You get to the. Now I want to kind of click a point on this one. And this is my point. It's a point there, all right? Now, what I want you to also do is, okay, so first let's do this, okay? Now you go ahead and you click on this number. Okay, so first let's get out of this one because we've already graphed. Now you click on here, right? And you do control menu and it will ask you to store variables. So you go to store. I'm going to call it x1. All I'm doing is, you just realize what I'm doing, all right? And press enter. What I'm doing is storing the coordinates of this point and calling them x1, and this would be obviously y1. I'm going to do the same thing. I'm going to highlight here. I'm going to go to the menu. I'm going to the menu. Again, I'm not in the right place, all right? So, okay. Excuse me. Yeah, you store the variable, all right? I'm going to call it y1 and I press enter. I'm going to summarize what I've done up until this point. We graphed y equals x cubed, or f1 of x is x cubed. I plotted a point on the function and I've named it x1 and y1, all right? Now let's go to 5.2 here and let's call this xval, the x value. I'm just going to call it xval. And I'm going to press enter and move on to the next cell here and call this yval. Okay. And now I'm going to capture. So the whole objective of this exercise is to capture all the points. So if you see, I can just move these points, right? I want to capture all these coordinates in here. So I want to fill in this data and you'll see the reason why, all right? Isn't it cool that you can just copy over all the coordinates from one application to the other? I really find it really interesting. Okay.
Ma'am, sorry to interrupt.
Yeah.
We have a question that a student has a doubt about how to store the variables.
Okay.
Yeah.
So you would go to menu. Okay. So if you were to go here, right? So your arrow is here. All you have to do is do control menu. Now I don't get the control menu because I'm already in a, okay. So let's do this again. So you go to menu, let's go to geometry, let's go to points and lines. I am doing another point, and let's say I'm plotting a point here. Okay, and now that I've plotted, I'm getting out of this application. Now you go here, you're in here, right? You go to control menu. Oh, I still don't get it. Just hold on. So hold on. Let me see if it is. Okay. So when you highlight, if you've seen, I've highlighted the part that I want to, if I want the coordinate that I want to store, and then you go on to store, right? So you highlight that, and then you go to control menu, and then you store it as a variable, right? You do the same thing. So if I go to store, right, you just write the name of the variable, what you want to do. In this case, I chose x1. In this case, if there were 2 points, it would be x2. And then you do the same thing for y2, right? So now I'm just going to escape this because I'm not really interested. So another opportunity for me to show you how to get rid of something that you do not want work, right? So this point here, I wanted to undo the action, and I've used control escape to undo the action, all right? So kind of to answer the question again, you would highlight the coordinate that you want to be stored. You do control menu and you would store it. So I've now stored it as x1 and y1. Right? Is it answered? Is the question answered?
Yes, ma'am.
Okay, all right. So then we go to 5.2, and then, right, we have kind of noted this as x value and the y value. And then you go in here, and then, okay, right, you go to menu. Excuse me. Oops. Okay, right? So you go to data capture, go to automatic, right? And I'm going to kind of store all the values here, and I'm going to use the variable x1. So I can go to my variable here, and this is the x1. So all I have done is capture all the values on that graph on the previous page will be stored here, okay? And I press enter. I'm going to do, so this point is this one here. It is at right now at 1.37, and it is captured here, all right? I go in here, I do the menu, I do the data capture, automatic, and I'm going to store it as y1, okay? So all your variables are stored here. I go to the variable, and I do y1, okay? And I press enter. Okay, now, I want you to do before we see the magic on the page. There's one more thing I want you to do. I want you to go ahead and press the tab. And now we are going to use scatter plot. Okay, we are going to use scatter plot. I want this scatter plot. Now, right now, maybe you just watch me do it, and we can go over this example next time because there's little time. All right, so I'm just going to show you how to do it, and you can watch for now. Okay, so here I'm going to store, you go to the variable, and now I will have my y values for the x, and I'm going to have, sorry, yeah, I'm going to have the x values for this one. And there's a reason why, you'll just see why, okay? Now what we have to do is, so there are 3 things I've done. The first thing, I plotted the function. I recorded a point on the function. Next, I want my intention is to move the point, and as I move the point, all these values will be caught here, will be captured here, and then let's see what happens. So what I'm going to do is, oops, what happened? Did it? Okay, so maybe it didn't. So here is an opportunity for you to watch again. Go to the variables here, the y-val, then go down. So go to tab, go to variables and xval, and I press enter. It was possible that I had not pressed enter. Okay, and now I'm going to kind of take this point and I'm going to move it. And what do you see? We have points appearing. We have points appearing, and this is a question for all of you guys who are attending the presentation today. I'm just being very gentle with this so that all my values are captured. And this is a question for the audience today, all right? What is happening? And why is it happening? Just trying to be really mindful that I want to capture all points. I'm going really slow over the function, really slow over the function, because I want to capture everything, you know, even this point here. And now it is moving on my function and I'm grabbing all the points. So I want people to answer this question.
We have an answer, ma'am, from Palak Salecha. She
Okay,
says inverse function.
very good, right? So this is the inverse function, because what I did was I captured all the values and I went ahead and I graphed here. If you go up, you see, I've graphed the x value, the y values for the x, and the x values for the y. And that's what happens in an inverse function, right? So that's what happens in an inverse function. So this is all for today, right? There are any questions? I can take a question or two. Is there a question for me?
Ma'am, we have a question that can you do the capture again?
No, not today, because I've got an appointment at 4 o'clock, but I can do that again. Oh, I can quickly show it to you. I can quickly show it to you. So, so what we are going to do is I'm going to go here and we can do this capture here, and we can do the menu. We can do insert. I'm going to undo. So I'm going to clear the data. All right. So that uh, you get to see what I do again. Okay. It is going to be just very quick data. And the reason I said no earlier is because I've got an appointment at 4. Okay, I cannot stay beyond 4. All right, so I can go back here. All right, you see everything is clear. And now I move the point. Right, and we'll do this again. If you are a regular attendant of these webinars, yeah. So if you see, so this is how you capture the data. How to link, right? Maybe we do that again another time, because this probably will have to, there's a lot of stuff to do in here. So we'll continue next time, all right? And we'll do this capturing of data and learning a lot about other things next time, okay? All right, thank you guys. Swati, can you take on from here?
Yes, ma'am. Yes, ma'am. Thank you so much for the session.
Yeah, thank you.
Yes.
I'll stop sharing, all right?
Yes, ma'am.
Okay.
Okay. So now that we have done with the session, can we have a short quiz on the mathematics that we have learned today? And I want every one of you to have a handle device in your hand, because you can do the calculations from your calculator. So please open on your Google, please type join my quiz, joinmyquiz.com. joinmyquiz.com, and the code is 505201. 505201. Everyone, please enter joinmyquiz.com on your Google and enter the code. You can see it in the chat box. 505201. I'll just start in 2 minutes. Please make sure that you have the calculator in your hand. Okay, I'll just share the screen and start the quiz. So here comes your first question. I hope everyone can see the question. Yes. In an quadratic function, what does minus b by a represent? What does minus b by a represent? Okay, we have 10 seconds. Quickly. Next question. How do I view the table in the calculator? How do I view the table in the calculator? On your calculator screen, how do you see the table? The timer is on now. 10 seconds. Yes, time up. Next question. Which value of x satisfies the equation? So this can be done using the numerical solver on your calculator. We had learnt it in the last session. Use the numerical solver. 30 seconds. Last 10 seconds. Quickly. Time up. Next, we have what is the solution to this system of equations? Use the simultaneous equation in your calculator. So it is in the algebra option. 30 seconds. Ten seconds. Quickly. 5 seconds. It's time up. So next we have the ninth question. What is the value of the expression when a and b values are given? So it is just the substitution of the values which can be done on the calculator screen. Last 15 seconds. The timer has started. Timer. So now let us see the scoreboard. Palak Saleja is on the top, and on second we have Sambhav. Okay, the next question is solve for x. Solve for x. So this we have already learned today. You all can just plot two graphs, one for LHS and the other for RHS, and then find the point of intersection. Or you can also use the polynomial tool on the calculator application. 20 seconds. Five seconds left. Yes, time up. Next 12th question we have. A model rocket is launched from the ground. Its initial velocity is 512. Its flight is modeled by an equation below. The equation is given. We need to find the height of the rocket after 5 seconds. So this is a short answer. You need to input your answers. Ten seconds. Time up. Okay, next question. 14th question. In which of the following situations will it be necessary to use this negative on the TI-Nspire calculator? So you can have more than one answer. You can have more than one answer. So answer all of them. 10 seconds. Time up. So now on top we have, all right. So these are the two options wherein you can use this negative symbol. So this symbol is nothing but a negative sign which is applied before any number. It's not the subtraction, it's the negative sign. Okay, last question for the day. Last question. Simplify. Under root negative 32. Yes. So now let's see. On number one we have, all right, the answer for this is fourth option. Okay, any questions from today's session? Any questions? You can just raise your hands and I'll unmute you and you can ask your question. I just want to show a couple of things that you were asking. Like the first thing I want to show is, okay, someone just asked that how do we store a variable. All right, so this is my screen. You all can see the graph page here. So let me just input a random function, a line. And as we have seen that we can plot a point on this by going to menu, geometry, points and lines, point on. So I'll just click anywhere, and this is how I got my coordinates. Now the question was, how do we store a variable? So the cursor needs to be taken near the x coordinate. So when I am on my x coordinate, I'll just click twice. I'll just click. So once you see that it is highlighted, I'll click Control plus menu. So once you see it is highlighted, or you can just right click. So when you're using the software, the right click is as you do it in the laptops. But when you are on the handheld, right click is nothing but Control plus menu. So when you right click on your X coordinate, here number 5, you can see the store option. So when I click on store, I can store this, let's say X1. So this is how I stored my first coordinate. You can see it in the bold. Similarly, let me show you again with my Y coordinate. I take my cursor over to the coordinate, and again the right click is a very useful feature. So when you are working on the software, the right click is nothing but the right click as you do on your laptops. But when you are using the handheld device, the right click is nothing but Control plus menu. So as soon as I right click, I again see store is on number 5. So I can just store it as Y1. So this is how we store the variables. Any more doubts? Chinmay, about inverse functions we'll see in depth in our next session. So it was just introduced today, like how do we solve inverse functions, how do we plot inverse functions will be taken in the next sessions. Previous recording, you can just write, you can just share your email ID, or you can just write it on this mail ID. I'm just writing my email ID. You can write it to me and I will share the recording. Yes, if you have no doubts, you can leave. And one more thing, our next session will be on 31st of October with functions. So on that day, we are going to see inverse functions, composite functions, and all of those. Thank you all for joining. See you on 31st of October.